It is finally time for that video that I've been promising y'all about the, I promised you I would work the math problems in the ACT practice packet. So here we go. I'm going to work on 10 at the time, 1 through 10, 11 through 20. So the file won't be too big to upload, and you probably get bored watching 60 problems at one time anyway. If you do not have one of these, and you probably do if you're trying to take the ACT, but if you don't, I'm going to drop a link down in the description box so you can access it online. It's the same thing. I suggest that you work the problems first. It's not going to do you much good if you watch me work on first and then go try to do it on your own. So go try to work the problems yourself, check your answers, and the ones that you have trouble with, come back here and watch me work it for you. Okay? So here's 1 through 10. Number 1 says, the numbers 1 through 15 were each written on individual pieces of paper, one number per piece. Then the 15 pieces of paper were put in a jar. One piece of paper will be drawn from the jar at random. What is the probability of drawing a piece of paper with a number less than 9 written on it? Now, probability is a fraction, it's a ratio of the number of possible or correct choices over the number of possibles. So if we have 15 pieces of paper, then we have a possibility of 15 occurrences. One of 15 things could happen. So how many of these things are the correct one? Well, if it's less than 9, that gives you 1 through 8. So you're going to have 8 out of 15, which is answer E. That's all there was to that. Okay, number 2 says, which of the following expressions is equivalent to negative 4x to the third minus 12x to the third plus 9x squared? So we just need to simplify this expression. Now you can combine terms that have the same variable portion, where the variable and the exponent match. So you can combine these two terms. Now a negative 4x minus 12 more x cubed is going to be negative 16x to the third. Nothing will combine with the 9x squared. So you're good to go there. And this is going to be answer choice J. Correct answer is J. Okay, number 3. When x is equal to 2, 10 plus 3, parenthesis, 12 divided by, parenthesis, 3x, parenthesis, equals. So this is just a simple substitution. We just need to substitute x equals 2 into the expression. So let's just erase the x. Now this was 3 times x. So when you substitute that 2 in there, that's 3 times 2, not 32. 3 times 2. And using PEMDAS, we're going to go to the parentheses first, go to the inside, and do what's in these parentheses. 3 times 2 gives you 6. Now we're still on the P part of PEMDAS, getting rid of parentheses. So 12 divided by 6 is going to be 2. Alright? So to clean this up, what you have at this point is 10 plus 3 times 2. Now, as far as PEMDAS go, we're through with parentheses. We have no exponents. The next step is multiplication or division as you come to it from left to right. So we're going to have to come down here and multiply first. 3 times 2 is 6, and 10 plus 6 is 16. So our correct answer is B for number 3. Number 4 says absolute value of 6 minus 4 minus the absolute value of 3 minus 8 equals whatever. Simple evaluation. Absolute value signs work much like parentheses signs do. They're grouping symbols. So we need to do what's in the absolute value sign first so we can pull that value out. 6 minus 4 is 2. Now what's the absolute value of 2? Well, it's just 2. Remember, absolute value actually has no sign. It's just the number of spaces this number is worth on the number line. And negative 2 is worth just as many spaces as positive 2. The sign just gives you direction. So the absolute value of positive 2 is 2. Minus, alright, 3 minus 8 is going to be negative 5. But when you take the absolute value of a negative number, it loses the sign. So now we have 2 minus 5, which is -3, and that is answer choice G. Number 5, the expression 4c minus 3d times 3c plus d is equivalent to. We look at this, and this is not an equation. There's no equal sign. This is an expression. There's 2 binomials. We need to multiply. Now you can just distribute the first number. Make sure you multiply it times both, the second number times both, or you can use FOIL, which is the same thing. It's just a little bit different order. So let's go ahead and stick with FOIL. I'm going to multiply the first 2 together. So 4c times 3c gives me 12c squared. Now the outside 2, 4c times d gives me positive 4cd. The inside 2, now I have a negative times a positive, so that's going to be minus. 3 times 3 is 9. Now instead of putting DC, I'm going to go ahead and put them in alphabetical order because multiplication is commutative. CD is the same thing as DC, and you want to keep them alphabetized. That way you'll know when something matches. My last 2, the -3d times d is going to give me -3d to the second power. So let's go in here and combine these 2 middle terms, your O and your I. So we have 12c squared. Positive 4 minus 9 is going to be a -5cd minus 3d squared, which matches answer number C. Okay, ready for number 6. Of the 180 students in a college course, 1/4 of the students earned an A for the course, 1/3 of the students earned a B for the course, and the rest of the students earned a C for the course. How many of the students earned a C for the course? Well, all we have to do is, and this is all numbers, so all we have to do is figure out how many made the A and the B, and then subtract it. So, of the total, 180, how many made the A? 1/4. So if you multiply 80 times 1/4, that's going to give you 45. Now, 1/3 of them, and anytime you hear that word of, 1/3 of, you know you need to multiply. So 1/3 of 80, which is the same as if you divide 180 by 3 and then multiply by the numerator, is 60. Now if I add these 2 together, I get 105. Alright, out of the total, out of 180, if I subtract 105, I get 75 students that made a C. And that is answer F. Okay, number 7. The number of fish, F, in Skipper's Pond at the beginning of each year can be modeled by the equation f of x is equal to 3 times 2 to the x power. So let me write that down. F of x is equal to 3 times 2 to the x power. This is the point where most students are thinking, oh, I don't know how to work this, but this is super easy, so just hang on. Where x represents the number of years at the beginning of year 2000. For example, x equals 0 represents the beginning of the year 2000. X equals 1 represents the beginning of the year 2001, and so forth. According to the model, how many fish were in Skipper's Pond at the beginning of the year 2006? Well, if 2000 was 0 and 2001 was 1, then 2006 must be x equals to 6. So all you have to do is put that 6 in here and multiply 3 times 2 to the 6th power. Okay, and you could punch that into your calculator real quick, or you can come off to the side. You're going to multiply 2, 1, 2, 3, 4, 5 times itself 6 times, and I've already done it, so let me get the correct answer. This is 64. So you have 3 times 64, which is 192. So that is correct answer B. Okay, number 8. Manish drove from Chicago to Baton Rouge. At 8 a.m., he was 510 kilometers from Baton Rouge. At 1 p.m., he was 105 kilometers from Baton Rouge. Which of the following values is closest to Manish's average speed in kilometers per hour from 8 a.m. to 1 p.m.? All right, well, first let's get our data out of here. Now, if he was 510 kilometers from Baton Rouge, and then later on he was 105, and we want to know how far he went, we need to subtract those. And 510 minus 105, he traveled a distance of 405. So that's his distance traveled. Now, the time was from 8 a.m. to 1 p.m., which is 5 hours. So now to restate the problem, he traveled 405 miles in 5 hours. All right, the question asks us for average speed, so that's a rate. This is a rate, this is a distance problem, and I just always fall back on the rate times time is equal to distance. I know there are other configurations that are snappier to use, and a lot of people have those, they spit them out all the time. But I try to just remember, memorize as little as possible. So rate times time is equal to distance. Now, what's our rate? Our rate is what we don't know. So this is what we're looking for. Our time was 5 hours. So 5R equals 405. Now you have a little equation to solve. So you're going to divide 405 by 5, and that's going to give you 81. That was his rate, kilometers per hour. And that is letter H. Correct answer is H. Number 9. In the figure below, E and G lie on AC. D and F lie on AB. DE and FG are parallel to BC, and the given lengths are in feet. What is the length of AC in feet? So that pretty much just describes the situation that we have here. And what we want to learn is what is the length of this whole side. Now we know the length of part of it. This first segment of it is 16. The only information in there that you really couldn't determine from just looking at the picture is the fact that these two lines are parallel to BC. And in geometry you have a rule, theorem or postulate, that says if you have a triangle and there is a line parallel to one side of the triangle, then that line cuts the other two sides into proportional segments. So we can set up a proportion. Now since we have two missing segments here, we're going to need two different proportions. So first of all, we can do 8 over 7. So this segment is to this segment, and then we can do 16 over x, and e to g is going to be x. Now we're ready to cross multiply and solve. So 8x is equal to 7 times 16, and then we'll divide both sides by 8. And let me get the calculator out so I don't make a mistake. That's going to give us 14. Okay, so this segment right here is now 14. Okay, now we're going to have to do this again with the other segments. So now we can do, and we can keep on using, now we're going to use 8. Let me get some more space. Okay, we're going to use this AD segment, which is 8. Now we're going to be comparing it to FB down here, which is 6. And then the 16 over the missing segment here. We could label it Y since we've already used X. But notice when you set up a proportion, you have to have some sort of a relationship. So this side is to the new side as this side is to that new side. Okay? And we're still going to cross multiply and solve. 8y is equal to 6 times 16. Divide both sides by 8. Therefore, y is equal to 12. Okay? Now, if we add 16 plus 14 plus 12, what do we get? 10, 20, 30, 42. Okay, and that matches to answer D. Correct answer is D. Okay, number 10, last one for this session. Katrina runs 15 miles in 2.5 hours. What is the average number of minutes it takes her to run 1 mile? Now, the fact that they put minutes in italics there lets you know they've got something up their sleeve. They give you your data in hours. So the first thing I'm going to do, and let me just write my information up here. She ran 15 miles in 2.5 hours. So if I want to change this to minutes, what am I going to do? 2.5 times 60. There's 60 minutes in every hour. So if I multiply that times 60, I will get 120 plus 30, 150 minutes. Okay, the problem asked me to find how many minutes per 1 mile. So what I'm looking for is the X minutes per 1 mile. Let me set up a proportion with the information I have. X minutes per mile. What did she do? She ran 150 minutes, 15 miles. Do you see how your proportion has to match? If you've got minutes over miles here, you've got to have minutes over miles here. Now you could flip it. You could have done miles per minute and miles per minute. But you just have to be consistent with whatever you set up to do. And we would cross multiply and solve. So I've got 15x is equal to 150. Divide both sides by 15. X is equal to 10. And that is going to be answer choice G. Okay, we're 1/6 of the way through, so 5 more sessions to go. I'll see y'all on the next one. Bye.